This is probability video number 8 from digital-university.org, and in this video we're going to consider another conditional probability problem, and also in the next video we're going to consider another conditional probability type situation, and that one will involve Bayes' theorem. And then upon completion of those two videos, we have a series of other videos where we deal with Bernoulli type probability situations. And in those videos, especially those latter videos, we're going to draw upon our knowledge from previous videos that we posted concerning how to solve different types of combination problems and also permutation problems. So if you just found us on YouTube and we're referring back to results or mathematical techniques from previous videos, and you're not certain or if you're not familiar with those math techniques, if you go to the website at digital-university.org and click on the combinatorics and probability section, there you can access the earlier videos that we were referring to. Okay, for this video, we have a problem that states, from a deck of playing cards, cards have been successively drawn at random, and we don't replace them. And it says, what is the probability that the third spade appears on the sixth draw? So what this means is that we drew 5 cards from the deck, and those 5 cards contain 2 spades with them. What is the probability then that on the sixth draw, that card will also be a spade? So we have it designated like this. E1 is the event that 2 spades are removed during the first 5 draws. And then E2, that will be the event that on the sixth draw, another spade was removed from the deck. And the way we have this then is that here we're considering the joint probability, that is, on the first 5 draws, 2 spades are removed, and on the sixth draw, a third spade was removed. And again, this event E2 is one of these conditional events, because for this to happen, it's predicated upon event E1 happening. During the first 5 draws, 2 spades are removed. Now this event is on the sixth draw, another spade is removed. And the probability of this joint event then is the probability of this occurring times the probability of this occurring. So what is the probability here then that if we randomly remove 5 cards from the deck, that 2 of them will be spades? What would be the probability of that occurring? Now, we know that in a deck of cards that there are 13 spades in the deck and 39 non-spades. So we have 13 spades and 39 non-spades. So for event E1, we can kind of think of it as splitting it into 2 tasks. Task T1 would be the selection of 2 spades, and task T2 would be the selection of 3 non-spades. We'll designate as NS. And the total number of ways that we can remove 2 spades times the total number of ways that we can remove 3 non-spades, those multiplied together by the counting principle, that then will be the total number of ways that we can remove 2 spades from the deck on the first 5 draws, with 2 spades and obviously 3 non-spades. Now, the probability of E1 occurring then, that would be the number of ways that we can remove 2 spades and 3 non-spades, divided by, and here we moved a total of 5 cards from the deck, so the probability of this happening, that is the probability of removing 2 spades and 3 non-spades during the removal of 5 cards from the deck, that's equal to the number of ways that this can happen, divided by the total number of ways that you can remove 5 cards from the deck. Well, let's just think about this. So that would be in the denominator here. So this is the number of ways that we can remove, or that we're designating T1 as the task of removing 2 spades from the deck, and task T2 we're designating as the removal of 3 non-spades from the deck. Now the number of ways that we can do this times the number of ways that we can do this task, that tells us then the number of ways that we can perform event E1, that is the removal of 2 spades and 3 non-spades from the deck. Well, if there are 13 spades in the deck, how many ways can we remove 2 of them? And clearly that is just this combination, because we have 13 spades, we're going to remove 2 of them. The order in which we remove them does not matter, so that's a combination problem. Now here is the removal of 2, or the removal of 3 non-spades is task T2. How many ways can we do that? Well, there's 39 non-spades in the deck. We're going to select 3 of them at random. The order in which we select them is irrelevant. So how many ways can we do that? And as you saw us do in the earlier combination videos, that's this expression. So this is the number of ways that we can perform task T1. This is the number of ways that we can perform task T2. We multiply them together, and that's the total number of ways then that we can remove 2 spades from a deck and 3 non-spades. And that then is the total number of ways that we can perform event E1, the removal of 2 spades from the deck, and obviously then the corollary is 3 non-spades. How many ways can we do that? That's what this expression right here is. Now the probability of E1 happening, that will be equal to the number of ways that we can remove 2 spades and 3 non-spades from the deck, divided by the total number of ways that we can remove 5 cards from the deck. Well, there are 52 cards in the deck. How many ways can we randomly select 5 of them where the order doesn't matter? That's this. So let's just tidy it up a little bit. This expression right here is the probability for the event E1 to occur. 13 spades of the deck, we're going to remove 2 of them. While that happens, we had removed 3 non-spades from the non-spades portions of the deck. Multiply these 2 numbers together, that tells us the total number of ways then that we can remove 2 spades and 3 non-spades from the deck. Divide that by the possibility of how many ways can we remove 5 cards from the deck total, and that will tell us then the probability of removing 2 spades from the deck. So this is equal to this binomial coefficient 13.2 times this binomial coefficient, 39/3, divided by this coefficient, 52/5. So let's just stop and make some room on the board here. We don't need this anymore. So now what we have is that the probability for event E1 to happen, the removal of 2 spades from the deck during the first 5 draws, and the removal of a spade during the 6th draw is equal to this times this. And this expression is the probability of removing a spade from the deck when there has been 5 cards removed during event E1, and 2 of those 5 cards have been spades. So let's think about this now. 5 cards after event E1, 5 cards have been removed from the deck. 2 of them have been spades. So there are 52 cards in the deck. After event E1, 5 of them have been removed, so there are now 47 cards left in the deck. There are 13 spades in the deck, but after event E1, we moved 2 of them, so now there are 11 spades left. So after event E1, where we have removed 5 cards from the deck and 2 of them are spades, we've changed the composition of the deck. Now we have this, 47 cards left, 11 of them are spades. Okay, well if I take 1 more card out from the deck, what's the probability that that's going to be a spade? Clearly, that's just going to be 11/47. So this expression here, if we can get a different colored pen, this is 11 divided by 47. So now we go back. Joint probability, that is, for event E1 to occur, 5 cards are removed from the deck, 2 of them are spades. That is equal to this times this, and this expression is this. This expression is 11/47, so the probability then of removing 2 spades from the deck when you withdraw 5 cards, and removing 1 more spade when you withdraw the 6th card, that joint probability is this expression, which is the probability of E1 times 11/47. And 11/47 is the probability of our conditional probability event here. And go ahead, do the math here on these binomial coefficients and multiply it by this, and I think it comes out to be something like 0.28. So that's the problem. Again, when we remove 2 spades from the deck during the first 5 draws, the probability of that event occurring is this expression right here. The total number of ways that we can remove 2 spades and 3 non-spades from the deck during the first 5 draws divided by the total number of ways that you can remove 5 cards from the deck. Then, when that event takes place, we've changed the composition of the deck. Now there's a total of 47 cards in the deck. 11 of them are spades, so the probability of drawing a spade out of the deck is 11 over 47. So multiply this times 11 over 47, and that gives us our joint probability of removing 2 spades during the first 5 draws and removing 1 spade out of the 6th draw from the deck. Okay, that's the problem. Hope it was worthwhile for you. Come back in the next video. We have one more of these conditional probability type problems, and this one will involve Bayes' theorem. So come back, join us for that video, and let's see how we can solve that type of problem.